Welcome Wildcats. Today we're going to be doing the final portion of section 1.1, which is titled End Behavior. So in this case we're going to be looking at what graphs do when they reach the ends in either direction. So just a raw definition, end behavior describes what a graph does as x goes to infinity in either direction. Let's take a look at the exact same two examples that we used yesterday. So here's that first graph. First question we have to ask ourselves is, does x ever stop moving to the left? Well, in this case, that answer is pretty clearly no. We talked about that yesterday. So since the answer is no, we have to decide what our y value does while that's happening. So as x gets smaller, let's do that differently. As x moves to the left, what does the graph do? Well, it keeps going down. The way we word that is, as x decreases, f of x also decreases. Or, as x approaches negative infinity, f of x approaches negative infinity. Now, those are the wordy ways of saying it. However, there are mathematical symbols we need to get used to. This is how a mathematician would write this. And we read it the exact same way that green section is written above. As x approaches negative infinity, f of x approaches negative infinity. So, that tells us our end behavior on the left. Now we need to look at our end behavior on the right side of the graph. So, does x ever stop going right? And the answer is no. So what does f of x do as x moves to the right? So as x moves to the right, what does the graph do? Yeah, it goes up. Now we word this the exact same way as before. As x increases, f of x also increases. And again, we can use those same mathematical symbols. As f approaches infinity, f of x approaches infinity. Let's take a look at the other example that we had yesterday. This graph, this quadratic graph. We ask the exact same questions and get the exact same type of answer. So, does x ever stop going left? No. So, as x goes left, what does the graph do? Well, it continues to go up in this case. So, as x decreases, f of x increases. As x approaches negative infinity, f of x approaches infinity. Again, this purple is the exact same wording as the green. It's just how we would write it if we were writing it in math instead of writing it in English. We do the same thing now that we've got our end behavior on the left. We do the same thing to get our end behavior on the right. So, does x ever stop going right? Once again, no. So if it keeps going to the right, what does f of x do? What does the graph itself do? In this case, that's perfect. It continues to go up. So we can word this the same way as we did before. As f of x as x increases, f of x also increases. And again, to write it in these fancy math terms, as x approaches infinity, f of x approaches infinity. Now, taking a look at asymptotes. Asymptotes is probably a term that you've not heard before. The definition of an asymptote is a line that continually approaches a given curve but does not meet it at any finite distance. No. I'm with you guys. That just No. However, I did reword this into what I like to call English. It's an asymptote is when a graph keeps getting closer to a line but never touches it. That's all it is. So it's something that sounds fancy and complicated, but really isn't. Let's take a look at an example. You're not going to see a graph like this in the future. You will see a graph like this in the future, but it's going to be a while. So, when we're looking at this, we ask ourselves, horizontally, what line does this not cross as we're moving to the left? And in this case, we see that it gets closer and closer to the x-axis. That would be the line y equals 0. We do ask the same question when it's going to the right. What line does the graph not cross? Again, the x-axis, which is y equals 0. So the end behavior of our graph, we do it the exact same way, except now we have, as x approaches negative infinity, we're not approaching infinity or negative infinity, we're approaching f of x approaches 0. Same thing on the right. As x approaches positive infinity, f of x is also approaching 0. So that's the end behavior when you have asymptotes. If it keeps getting closer to a number but doesn't actually cross it, that's what your end behavior looks like. However, asymptotes don't have to be at the end. This graph is a perfect example. It has what we call a vertical asymptote. What is this one? Well, we can see it's right there in the middle. It never actually touches the y-axis. But if the y-axis is the vertical asymptote, what's the actual name of that line? Because we never actually use x-axis or y-axis as the name of an asymptote. This is never, ever, ever what we do. The reason for that is because those aren't actually the name of lines that we can put on a graph. So, the y-axis is what line? Since it's vertical, we know that it's x equals, but what does x equal? In this case, we're right in the middle, so it's 0. Our vertical asymptote is x equals 0. That is the entirety of section 1.1 notes. You guys now have all of the knowledge you need to be able to complete all of the problems that have been assigned to you in 1.1 on my.hrw.com, or you can find it under HMH Player on Clever.